Welcome back to my channel after a long time. So I could not post videos for some time back. Today I'm going to bring up a video regarding instructions about your upcoming class 12 CBSE Board Practical Exam. I have been conducting this exam over the last approximately 15 to 20 years, going as external examiner as well as an internal examiner. So I'll be pointing out all those specific points where children tend to make mistakes. So I hope this helps. Note them down. I intend to post approximately 3 to 4 videos to cover up the various aspects, short videos to give instructions, and then just helping you revise the titration salt analysis for your head, right? I'm uploading this video today to give you instructions about the upcoming class 12th chemistry board practicals, and I would give you instructions regarding the syllabus, the attempt, as well as some inputs about the various practicals, how to go about. So let us start without wasting any time. First, I hope that you already know about the total weightage of marks. The total practical exam is for 30 marks weightage, 30 marks. Your theory is 70 marks. Practical exam is of 30 marks, out of which the distribution of marks is volumetric analysis, 8 marks, salt analysis, 8 marks, content-based 6, project work 4, class record and viva is for 4 marks, and total marks are 30. So class record and viva, actually the viva can be from the project as well as from the class record. Now, some teachers prefer to take viva from one of the theory chapters, although in the instructions proposed by the board, suggested by the board, they have mentioned that the examiner is supposed to ask viva questions based on your project work as well as your practical exam. So focus more on project and the practical copy, that is all the experiments that you've done in your copy. You should have a complete knowledge about the whys and why nots of every experiment, right? Focus on those concepts for viva, and I'll be sharing some important viva questions. If you do those, I don't think you would need anything beyond that. Now, what are the board suggested topics for project? Although you must have already made the project. So these are the suggested project topics suggested by the board, or any other experimental topic within the sphere of your +2 study can also be accepted. It has to be something which is experiment based. And I'll also tell you what are those important components that you should keep in mind while preparing the project. Regarding the project, the things that you have to be careful about, what are the components that your project should have? The cover page where the title is written, and you have submitted by on the first page, where you can write your teacher's name here, Department of Chemistry, right? Department of Chemistry, and your school name. Under the teacher's name, submitted by, you have to have your name and then your class, whatever it is, class 12th, non-medical, medical, and here roll number, and you are supposed to write the board roll number here. Now, the next page has to be the acknowledgement sheet. Acknowledgement sheet covers you thanking various people who have helped you in making this, in the completion of this project. So this is, I would like to thank. So whosoever you want to thank, and this page should be signed by you, your signatures at the end of this page. Clear? And then we have a teacher certificate. A teacher certificate. This page has to be signed by the teacher, and don't write anything dramatic here. This is simply to certify that this project has been made by your name here, your name of class 12th, medical or non-medical, whichever section you are, on the topic under the guidance of the name of your chemistry teacher, and then the teacher's signatures. This is the teacher's certificate. Then the next page has to be the index. So index should explain all the topics that you've covered in your project. And finally, this is the last page. This is the last page of the project, and this is the bibliography. Now, what is the purpose of bibliography? Bibliography basically deals with all the references that you've used for making your project, names of the websites, books, anything. So please do not write here yahoo.com. This is incorrect. Not to write yahoo.com, not to write wikipedia.com or .org. It has to have complete URL of the site that you've used while making your project, the sites from which you've taken your content. The complete URL, the address is required, not just writing google.com or wikipedia.com or yahoo.com. This is incorrect. It has to be a complete URL. Please note this. And in case you are mentioning names of the books, the name of the book should have the name of the author, class, subject, a detailed description about the book, right? And these are the main components of the project that you should have, and it should be properly either spiral bound or in a file. Now, this is the format of the question paper, right? This is just a sample paper. You'll have name of the exam here, the year in which this is taking place. So this year, it's going to be 2025, class 12, chemistry. This is the subject code. Time allowed 3 hours, maximum marks 30, and we are going to put the date here. Now, the questions can be like, first has to be volumetric analysis, which is for 8 marks. And the question here, the question written is prepared 250 ml standard solution of M by 20 Mohr salt. Using it, determine molarity and strength of a given solution of KMnO4. Or it could have been prepared 250 ml standard solution of oxalic acid, any given concentration of oxalic acid, and then determine the molarity and strength of given solution of KMnO4. Any one of the titration out of the ones that you've done in your practical record. Okay. Next is analyze the given salt for acid and basic radicals using suitable physical and chemical tests. So this is going to be analysis of the salt. Total 8 marks. The 8 marks, children, are divided into practical part. Practical means identification of the salt, and then there will be marks for the written part. So the marks are divided into, let us suppose you have nitrate ion as your acid radical, and this is a concentrated acid radical, but you identify, let us say, nitrite, or you identify it to be carbonate, which is a dilute acid group radical. So the credit that you're going to get for this is going to be less. Why? Because you could not even identify the group to which the radical belongs. Clear? But if instead of nitrate, let us say you identify it to be something like bromide, you get a little more credit. Why? Because you could at least identify the correct group of radicals. You could not reach to the right answer. So these 8 marks are going to be divided into your identification, correct identification, and into reporting the salt analysis correctly. So then the next one is, the third question is going to be identify the functional group using suitable chemical test, or here there could be any content-based experiment depending on what you've done in school. It could be chromatography, or it could be based on thermochemistry, or any other experiment that you've done, right? And then we have, as I spoke, project work, class record, and viva. This together is going to be 4 plus 4 marks for presentation, for a good choice of the topic, good content, and along with that, viva. So basically, this total is going to be for 8 marks. First, I'm giving you instructions regarding reporting your salt. Reporting the volumetric analysis, right? Let us say you get M by 20 Mohr salt solution and determine molarity and strength of a given solution of KMnO4. You're going to write aim. You're going to report exactly this way in your practical, in your final answer script. And yes, before I explain this, please take care of keeping your answer script safe, children. Do not keep your answer script on the slab, on the working slab, because if by mistake something spills on it, you spill something on it, or by mistake some of your neighbors by mistake they spill something, your sheet gets spoiled, and we get, your examiner is going to get just the required number of board sheets, may not have any extra sheet to provide you. So if your sheet gets spoiled, it goes exactly that way only. Okay, you can get additional sheets, but the main sheet is provided only once. So take care while writing. You must place your sheet on the stool on the side. You get a seat to sit, so you can keep your sheet on that while you're working on the slab. Avoid uh, taking keeping your sheet on the slab, and also carry a cardboard. Very important, a transparent cardboard you must carry with your practicals, and then carry one rough cloth, basically a cleaning cloth, okay, in order to clear any mess that you happen to create. So then the main things that you need to carry are lab coat, your white lab coat. Then you need to have a platinum wire with you to do the flame test, project, properly bound, spiral bound, or in the form of a file, your practical copy, which should be nicely, neatly, freshly covered. Okay, so these are the, and a transparent cardboard plus your stationery, right? These are the main things that you need to carry for your exam. Now, what all things you're going to be asked to write? You're generally asked to write the aim. You are not asked to write most of the times. It depends on the external. They might ask you, but most of the times apparatus is not asked to be written. You're asked to write the aim, then you're asked to write the molecular equation, the ionic equation, the overall equation. This depends on your external examiner. Some might ask you to write a complete overall molecular equation. Some might ask you to write the steps also. And some might ask you to write just the ionic equation. And some may expect you to write both. So it is suggested that you learn both molecular as well as ionic equation with balancing, children, because you tend to forget balancing. And if you sit down there to do, you might mess it up. So just learn this, write this equation 5 times, learn it repeatedly so that you don't make any mistakes. And remember, anything written incorrectly in your sheet, that becomes permanent. Like nobody can sympathize or give you any sympathy marks. If one or more viva questions go wrong, we can, ignore that, considering that you've gone nervous, or maybe you, like the way you expressed it was not right. But whatever is written, printed on paper, that goes as such. So just be careful to cram, to learn all that content which is to be written there very, very thoroughly. So then the next thing they will ask you is to write an indicator. Indicator for both the titrations you've done is KMNO4, then endpoint colorless to permanent pink. Observations, make the observation table. What are the important things to be kept in mind while making the observation table? You need to have serial number, initial reading, final reading, volume used. Now, what mistake has to be avoided? What mistake can you make which you have to avoid? You don't have to write ml in the first 2 columns. This is a big blunder that children do. This reading is not in ml. You don't have to write ml in the first 2 columns. ml is to be written only in the 3rd column, because what really happens when you are using a burette? Now, this is a very common, viva question as well. When you pour KMNO4 into a burette, right? It's very sad to say, over my last 20 years of experience, children don't even know what are the graduations in a burette. So burette is graduated like this from 0 to 50, and must remember that a burette does not tell you about the actual volume of liquid contained in it. When you put liquid in a burette, you just fill the entire burette with the liquid, right? Till here. So let us suppose you draw out some liquid. Let us say when you poured the liquid, your initial reading was either 0, or it can be anything. You don't have to essentially start from 0 every time. Your initial reading can be anything. If it's, let us say you have poured your liquid till 10 ml, right? So can I calculate the total volume of KMNO4 that is present inside the burette at this moment? No. a burette does not help us to calculate the volume of liquid present inside, then what is the purpose of a burette in measuring volumes? Initial reading we note down as 10. Initial reading. This is initial reading, as you can see now. Initial reading is 10. And then we're going to pour out some liquid and note down the new liquid. We are going to pour out the liquid from here to do the calculation. And let us say the new reading is 15. So final reading is 15, which will tell us that the volume of liquid drawn out, is going to be 5 ml. So a burette is used to measure volume of liquid that is drawn out, not the volume of liquid which is present inside. So that is why when you note down the initial reading, you don't put ml with this. Okay. Final reading also, ml is not to be written. Please make a point. Fine. Remember this. And volume used finally, that is obtained by taking final minus initial reading, that is the volume used. Now, some misconceptions, some children every time start to, fill the burette to 0. No, it's not needed. For every reading, you don't need to essentially fill it to 0. Your initial reading can be anything. Whatever is the initial reading, note the final reading. The difference should be quoted here. And remember, these readings, the first reading can be a rough reading. The next 3 readings should be concordant. What is the meaning of concordant readings? Readings that differ by a maximum of plus minus 0.05. So these 3 readings will be considered good readings if they differ by only plus minus 0.05. Either they are same or they are with a difference of plus minus 0.05. The first reading is a rough reading. So something very interesting I'm telling you. One of the years I'd gone to one school and a child had taken all the 3 readings, and then the child asked, "Oh ma'am, sorry, I forgot to take the rough reading. May I take it now?" So do you understand the joke in this? So once you've already completed your experiment, there's no purpose of taking a rough reading. What is the purpose of taking a rough reading? Rough reading is taken initially so that you get an idea approximately where are you going to get your endpoint. And then in your second, third, and fourth readings, you let the liquid out slowly, drop-wise, so that you don't miss the endpoint. That's the correct way of taking the reading. Okay. Then mean of 3 concordant readings to be taken like this, reported up to plus minus 0.1 ml. That means to first decimal place. These readings are to be noted to second decimal place. And this final result is to be quoted up to first decimal place. Clear? And this again would vary from examiner to examiner. Some would not want you to take mean. These days, some examiners just want you to pick up one concordant reading or the reading that they sign. So while you're taking readings during the exam, the examiner is required to, observe one reading and put a signature there. So a reading which the examiner signs, some examiners want you to do your calculations using this reading, whereas some want you to use the concordant. So you can just follow the instructions that are given to you during the practical exam. Clear? And we call these as titer values. Titer values. The readings of titration are called titer values. Using this word, there was a question in the previous JEE as well. Okay, just remember. So you must know the technical words to answer confidently and to create, a good impression to the examiner. Okay. Now, regarding the calculations, the first set of calculations involve to calculate weight of Mohr salt required to prepare 250 ml of M/20 solution. So you have to show here how you prepared M/20 Mohr salt solution. So how did you prepare M/20? Supposing you want to make 250 ml, 1/20 is the molarity. Weight is what you need to calculate, how much weight you will take. 392 is the molecular mass of Mohr salt. 250 ml is the volume of solution that you want to make, and this is 1000. Okay, similarly, if you were doing this for oxalic acid instead of Mohr salt, you would put here the molecular mass of oxalic acid. So when you solve, this is the weight of Mohr salt that you're going to take. So you're going to take this weight of Mohr salt, add water to it to make the total volume to 250 ml, and that's how M/20 solution will be prepared. I repeat this point, children. we make standard solutions in a volumetric flask, which is roughly of this shape, and it has one graduation, and on this bulb is written 250 ml. So what you're going to do, you're going to dissolve this 4.9 gram into small amount of water, pour it into this volumetric flask, and then add more water till the final volume becomes 250 ml. Remember, we do not add 250 ml water to 4.9 gram, but we add water to 4.9 gram till the total volume becomes 250 ml. Very important for you to understand. This can also be an important viva question. Okay, once you've written this, the second part of calculations is to calculate strength and molarity of KMnO4 solution. So you're going to use your equation M1V1 upon N1 is equal to M2V2 upon N2. In this case, this N1 stands for the stoichiometric coefficient in the balanced chemical equation, or you could also use N1 M1 is equal to N2 M2 V2, depending upon how you have been taught in your school or how you have written it in your copies. If you're using this formula, then if this is for KMnO4, then N1 stands for the N factor of KMnO4. And what is N factor of KMnO4? It's 5. Why? Because KMnO4 changes to Mn2 plus. That means plus 7 oxidation state is changing to plus 2. That means N factor is going to be 5. Similarly, this side, whether it's Mohr salt or oxalic acid, you'll have to take N factor of those. Oxalic acid N factor is 2, and for Mohr salt, N factor is 1. Right? Okay, in case you want to use this equation, then the N1 and N2 will come from the balanced chemical equation. Like for KMnO4, N1 is going to be this, the balanced stoichiometric coefficient in the balanced equation. And for Mohr salt, it's going to be this. Or you can take it as a ratio of 1:5. Clear? So then writing the result is also mandatory. Whatever you finally get, you're going to write the result like this. Now, sometimes children, some externals, they ask you to do these calculations using the general calculation method. They want you to do a general calculation first. General calculation means we are going to assume the burette reading to be VML. Assume the burette reading to be VML, and then put M1V1 upon N1 is equal to M2V2 upon N2. How will you substitute the values? M1 is KMnO4 molarity that we need to calculate. V1 is the burette reading, which we are going to keep as V. Right? This is 2. This is 1/20. This is 10 and this is 10. Another mistake that you children tend to do is that this Mohr salt volume is 10 ml and not 250 ml. 250 ml is the total solution that you prepared. But out of that 250 ml, you have only pipetted out 10 ml. So this value has to be 10, not 250. These are the common mistakes that you children make, which you have to avoid. So here you're going to get the value of molarity. You will be getting the value of molarity as you cancel this off. You're going to get V by 10. This is molarity. And then you're asked to calculate the final molarity by putting in the value of V. Let us say the noted V is 5 ml. So 5 by 10 or by 100, whatever you get, you're going to substitute and get your final answer. Clear? So you can do your own calculations for this. Think this once again properly so that you don't have, when you solve this, this 2 is going to cancel off. This is going to be 10. This is going to cancel off. And you're going to get 1 upon 10 V. So when you put the value of V, it's going to be 10 into 5. That is 1 upon 50. And then you can continue with molarity into molecular weight. Now, sometimes you might be asked to write precautions as well. So just memorize 2 to 4 important precautions and precautions regarding the usage of each one, right? I'll just tell you important precautions. If we are talking about, let us suppose the burette. So what are the important precautions? A burette must be rinsed. And readings to be taken at eye level. Readings should be taken at eye level. There should be no air bubble. This is very important. No air bubble before you start your readings, right? And you can remove your air bubble. I have done videos, detailed videos about these volumetric analysis. I'll post the links so you can see those to check the experimental components. Okay, no air bubble, and very important, remove the funnel before you start your readings. Because if you're taking your reading with the funnel on, that's a direct deduction of credit. Clear? In case we have to write about a pipette, then rinse the pipette. Rinse. And what is the meaning of rinsing and what is the difference between washing and rinsing? Washing is simply with water, just to clean it. And rinsing means pouring the liquid that you're going to finally pour into it. So just taking small amount of the liquid, pour it so that the inner walls of the burette or the pipette, they get coated with the liquid that you're going to finally pour into it. This is to avoid any errors. So videos on this also have been uploaded, and in the detailed videos on volumetric analysis, I've explained all this. I'll post the links. I wouldn't discuss all this again here so that this video doesn't become unnecessarily long. So rinse, then pipette. Again, there should be no air bubble. Okay, and avoid holding it from the bulb. And what is the purpose? Why we should not? What is the bulb? A pipette is like this. This is the pipette. Okay. And we use pipette pumps to suck liquid into it. And it has one single graduation. One single graduation. Let us say this is a 10 ml pipette. So this is a single graduation and we have to see the lower meniscus because we are going to take a colorless liquid here. So lower meniscus has to be checked. There should be no air bubble inside. And we don't hold it from here. We don't hold it from here. We hold it from here. I hope these points are clear. Now, these are the instructions regarding salt analysis. I am giving the instructions regarding salt analysis here, children. So you have to report it exactly the way you have done in your copies, in your practical files. Exactly that way you have to report here. In this case, I am giving you example of writing down lead acetate. Okay, so in your sheet, you will start with aim to analyze the basic and acid radicals in the given salt. Then you're going to make these columns exactly the way you do in your copy. Only this column is not to be made. This is just, viva questions related to each concept. These are just extra viva questions. You don't have to write this part. So here, 3 columns: experiment, observation, and inference. And then the first one is preliminary test. First, you have to write the preliminary test. Under preliminary test, color, smell, dry heating, and flame test. And what are you supposed to write? You have to write down the observation as well as the inference. If any of these is missing, your credit is lost. So learn this very carefully. Then identification test for acid radicals. The next is identification test. Identification test means we are simply going to add dilute sulfuric acid to small amount of salt. Very important, we are doing this identification test for acid radical with the salt and not the solution. We are doing this with the dry solid salt. So to a small amount of salt, add dilute sulfuric acid. Please learn it carefully. This is dilute sulfuric and not HCl. This is salt and not solution. And then just note down your observations and based on that your inference. In case dilute sulfuric acid shows no observation, no change, and all these radicals are absent, then we start with concentrated sulfuric. Okay, this scheme has to be followed. In case concentrated sulfuric also shows no change, then you're going to start with identify for sulfate or phosphate. Clear? Now, after this, we are going to write confirmatory tests for acid radical. Once the acid radical has been found, like acetate is present, so confirmatory test for acetate, any two confirmatory tests, whatever you've done. You don't need to write three. You can write just two confirmatory tests depending upon what you've done in your school. So that completes acid radical analysis. And while writing down this last inference column, children, when you're doing concentrated sulfuric, that is identification test, there we write the ion is present. Identification test, we write ion is present. For confirmatory test, we write the ion is confirmed. And in preliminary test, we write it may be present. Preliminary test. Here, we always write maybe. It is may be present or may be absent. Preliminary is always may be present, may be absent. Identification is present or is absent. And in confirmatory, it is confirmed. And then after this, we have identification test for basic radical. Identification test for basic radical. Here, we are going to do the test for with aqueous solution. So to the aqueous solution of the salt, added dilute HCl. If you get observation, you quote the inference. If it is not, then you just keep on performing. This was a group 1 radical. So it was short and simple. It finished here. If, let us say, you get a group 6 or a group 5 radical, you'll have to always start with group 1 and then say no change, group 1 absent, then go ahead for procedure of group 2, no change, group 2 absent, exactly the way you've written in your copies. Okay. And then we have confirmatory test for basic radical, in this case lead ion, 2 confirmatory tests. Again, in this column, you're going to write lead ion is confirmed. And writing the result is also mandatory. You will end your experiment with the basic radical was found to be this, and acid radical was found to be acetate, or whatever you get. So next is the functional group analysis. Functional group analysis, again, the way you have done in your practical files, you have to report it exactly that way. There are marks out of these total 6 marks will be marks for identifying, plus some marks will be for the written part, right? Total 6 marks credit for this. And it's not essential that you get functional group analysis, depends which content-based experiment you've done in your school. So your teachers will give you instructions regarding that. So in my next video, I'll be posting some important viva questions and some more instructions about how to go about. I hope to begin with this helps. So thank you, children. Have a good day and good preparation. Prepare well. And the most important thing that before I close that I would like to comment, please keep your behavior very nice. Maintain very good discipline in the lab, because if your behavior irks the external, right, in any way, if it's offending, it's basic human nature. Offending behavior will put off the external, and whatever best credit you are capable of getting, you might end up getting less than that. Okay. So most important aspect of your practical score and your practical marks on that last day, its last day is like you are going to go and reap the harvest of your 1 year's hard work. So I think 3 hours of behaving well and keeping yourself into the best form of discipline should not be difficult, because you're going to carry home outcome of your 1 year's work. Okay, so don't offend your teachers, neither your internal nor your external, so that it all ends up well. It's going to be good. Go relaxed, go well prepared. So all the best, children. And please subscribe to my channel and like the video and share further. I intend to be more regular in posting and helping you in your journey of NEET, JEE and Class 12th boards. I hope this helps. Have a good day. All the best, children.